Hello, this is Josh from Zhang, and this is my revision video for problem set 7. So the main questions I struggled with were number 1 and 3. So for 1, I did the programming, but the numbers in my table were not exactly correct. So they should be the ones as seen in the table here. But it's pretty intuitive to see that the algorithm with the bigger numbers are faster because there are more ring instances, clusters, instances, and hard graphs that it can solve, as opposed to BFS and exhaustive that have more instances and graphs that time out after 10 seconds. And this checks out with our theoretical knowledge because exhaustive search should take this amount of time, O of m times 3 to the power of n, and BFS should take O of 1.89 to the power of n as well. There's also a visual explanation of this. You can just visualize them as rings of nodes strung together. BFS gets through that very slowly, and so does exhaustive search. So brute force, basically. SAT solver is a lot quicker than this. And then to move on to 3. So yeah, it's good to take a second look at number 1, getting the numbers correct, and justifying your intuition, your theory. So for number 3, I understood the goal of the proof to use logic and Boolean formulas to verify for conditions. At least one CS concentrator is assigned to any member spot. And you can't have two concentrators, we'll call them A and B, to the same spot. You can't assign one person to multiple spots, right? C and D spots. And for every language, you need someone that knows it. So in particular, I messed up by conflating some of these conditions. I started off trying to prove condition 1, but ended up proving condition 3. And it's important to keep clear of which clauses are for which conditions. But yeah, in the end, it's a lot of just like choosing combinations. Like for example, this one ends up being, uh, choosing two from all of the concentrators for each one. So it ends up simplifying to a quadratic time. And this is the same one, except instead it's k squared instead of n squared. That really helped me to understand this, thinking about it in terms of like a binomial coefficient. And that was really helpful. 4 was a very specific way of constructing our Boolean formulas, and it makes sense. We basically just want to suppose we have a set of students that know a language and they construct it accordingly. And I think I skipped over number 1, but yeah, this one is just constructing K clauses to make sure that there's one CS concentrator there. And I did mess up a little for the proof of runtime. Basically, I messed up a little by saying that we had O of kn squared plus m runtime. That wouldn't be incorrect to say that there are that many clauses, but the runtime more specifically is this, to be a little more precise, because we just add up the runtimes for each set of clauses that we take to verify the 4 conditions we have laid out. There's also a proof of condition, a bidirectional proof we do for completeness and soundness. And those are good to look at too. I took a good look at them and reviewed my solutions. I think I understood, the proof strategy for how to justify our Boolean formula phi. So that concludes my revision video. Yeah, one more thing about the runtime, like we want to specify that this is the runtime. It's a little different in terms of the big O notation from the number of clauses we have. So yeah, that concludes my revision video.